Well, good morning, everyone. Thanks for coming to my presentation. It's kind of tough following a guy that just rolled out all the rules. But you can critique me, I guess, as we go through this. You're in the cartographic narrative session here. I just popped this slide up so we sort of get grounded what that means. My talk is, what's that map telling us? This is a story, and I'm going to be kind of a storyteller here, telling you a story about a story and see if I can weave it into the story of cartographic narratives. It takes place in Colorado, in an adjacent community to Colorado Springs. Let me see if I get mine. I don't seem to have a mouse here, so I'm just going to wing it. So this is Pikes Peak and Garden of the Gods in Colorado Springs, and Manitou Springs, the community, is at the base of Pikes Peak. And so in 2012, we experienced a wildfire, and as you might be aware, wildfires are becoming quite prevalent in the West. We had ours in 2012 that burned right up to the city limits. This isn't a story about the wildfire itself, but what comes after the wildfire. What comes after wildfires is typically you have flooding. And so we had this flood event, and that's what this presentation is about. I published the link to the story in my abstract, so hopefully you had a chance to review it. If not, you can go back and explore it after the presentation today. Manitou Springs is situated at this confluence of these watersheds. These are the three watersheds above Manitou Springs. It drains about 100 square miles of mountainous terrain into the center of town. It's a real vulnerable situation. When I sat down to write this story, what I wanted to do, as Ann shared with you, I've been working in the area of sustainability and resiliency for the Air Force globally. And so I've been paying attention to climate change specifically and how we can take steps to be more sustainable and resilient to these changes. So when I sat down to write this story, I identified what I wanted to achieve, which was a need to achieve a better level of flood resiliency in Manitou Springs. And so the target demographic that I wanted to target in my story is elected officials, potential funding partners, and the City of Manitou Springs staff and residents. So with that, I'm going to get right into it here. So this is running in a browser. I open the story with a magazine-style graphic in a portrait format. And it's real similar to the story maps that you experience with ArcGIS and what Tim just explained to you, this whole format of telling stories in these sort of scrolling formats. So you scroll into this, and this is pretty minimal, so I'll just read it to you. So it announces it's a story about the 2013 Williams Canyon flood. The story begins with the 2012 Waldo Canyon fire that burned 18,000 acres in 18 days, impacting 2 counties, and it destroyed 347 homes. So I display this graphic, and this is a map of the footprint of the fire. This is the area that it burned. I do a delineation of Williams Canyon. That's the lighter color down at the bottom. And you can see it drains right into the center of Manitou Springs. So it's one of those 3 basins you saw in that introduction map in my PowerPoint. So then I talk about Williams Canyon. It's a sub-watershed of Fountain Creek. Williams Canyon drains an area of 1,700 acres or 2.71 square miles over a distance of 4 3/4 miles. This canyon plunges 3,200 feet in elevation. It travels through a steep-walled limestone canyon, reaching a confining width of 20 feet. So this is an image I captured up in the canyon. This 3 square miles of mountainous terrain drains through this little opening here. And then the severity of the Waldo Canyon fire altered the forest floor in Williams Canyon. Altogether, 78% of the canyon burned. 14% of the canyon was high severity burn, 46 medium, and 18 low. So I built this severity map so you could see how much of it is severely burned. Again, I did a depiction of Williams Canyon. I got a pie chart down there that illustrates those metrics. The moderate to high severity areas are 60% of Williams Canyon burned through forest ground cover, leaving few to no organic soil organisms remaining on the surface. The situation limited the ability to absorb water and prevent erosion, resulting in a high velocity water runoff situation. So this photograph was actually something I captured about a year after the fire. You can see there's a little bit of vegetation coming back, but there's not much on the ground. When that rain comes down and hits the ground, there's nothing really to absorb it. So during the afternoon of August 9th, 2013, over a period of 35 minutes, 1.38 inches of rain fell on the upper Williams Canyon watershed, considered a 25-year event. Two factors contributed to the intensity of the flood situation: the severity of the wildfire burn and the steep, narrow terrain within the canyon. So this is a photograph, a drone photograph that was captured midway in the canyon. You can see the steepness, how narrow it is. This was just taken a couple months ago. You can see the recovery is coming along. This is 10 years after the fire. Not much in the form of tree recovery, but there is some ground cover starting to show up. Following the 2013 flood, a $6.1 million, 1,600-foot-long flood control channel was built above the pre-existing box culvert intake on Canyon Avenue. The channel features a large sedimentation basin at its midpoint and a series of debris nets to mitigate larger material carried out of the canyon during higher intensity rain events. So I have a picture, just a static picture of that channel, what it looks like. And then I inserted a video clip here just to show its functionality, and I won't run this whole thing, but you can see the debris net there. It's pulling that, mitigating that debris that's coming down out of the canyon, and then that's the 2,000 CFS capacity channel behind it. Each storm that produces significant runoff out of Williams Canyon carries out rock, mud, and debris. A fast-track maintenance effort is required to keep the flood control channel fully functional. The City of Manitou Springs Public Works Department is tasked with the cleanup after every storm. The primary vulnerability to Manitou Springs from flooding caused by Williams Canyon is the pre-existing underground box culvert that carries stream flows from the flood control channel underground to Fountain Creek. Overflow floodwaters exceeding the box culvert capacity flow down Canyon Avenue onto Park Avenue and through Soda Springs Park, causing significant risk to public safety. So this shows where it comes into town, into the neighborhoods. Here's this channel they built. It hits this choke point where it transitions into this underground box culvert that runs under Canyon Avenue. Its capacity is 400 CFS. Everything above that goes through this overflow and runs right down the street. Engineers designed the 2,000 CFS capacity flood channel to contain and reduce the velocity of up to a projected 100-year flood event. So I created this chart, pretty simple chart, that just correlates the amount of rainfall, the amount of CFS it generates down the canyon in pre-burn and post-burn conditions, and then I put these benchmarks in here. I worked with a retired USGS hydrologist that helped me with the metrics. We established what the paleo flood capacity is in the canyon. It's over 4,000 CFS. The August 9th event, the capacity of the flood channel, and then the capacity of the underground box culvert. So the last frame in this introduction section, I lay out annual precipitation amounts vary considerably in the region from year to year. The intensity of storm events is predicted to increase due to climate change. USGS installed a seasonal stream flow site in Williams Canyon that went online in 2014. The site is equipped to collect and transmit real-time stream flow and precipitation data. Due to the funding reductions, data collected at the site was discontinued in August 21st of 2020. So in this final frame, I go into a larger scale map. I I call out these different data acquisition locations and show the location to the city. I list the metrics here. This is a 10-year set of metrics on the rainfall. You can see it varies from about 11 inches to just over 30 inches in 10 years per year. And then I call out in this red box an even larger scale section of this map that I'm going to use in the next section of this presentation. And then I've got a set of instructions on how to navigate the next section. I'm not going to read this to you because I'm going to walk you through it. So at this point, this is the introduction section. You close this out. There's a little X up here in the corner. And then it brings you into this next section. And the next section uses this inset map as its navigational element. So this has a key, just like a regular map. The key corresponds to how to use this and how to move around in this section. And this is a nonlinear segment. So we're starting up here where the canyon drainage actually enters the city into the neighborhoods. These little blue dots are the places where I've done this. As you can see me scrolling around here, this is interactive VR shot from a drone from 100 feet in the air. So I went around town and I shot 7 locations of drone imagery and I stitched them together into these VRs. And that becomes sort of the overview element. And then I added this, you can see this little, it's called radar, this little highlighted element tells you which direction you're looking from the dot. So what it does is it starts to bridge that gap of the abstract nature of a map into the real time, the real scene photographically. So you can see this, here's this terrain here. As I scroll around, that's this terrain here. You can see the roads, you can tell where you're looking. I come back around, here's my Highway 24 bridge. You can see there's the highway. So it really, again, I've stepped the viewer down into the actual scene here. And so here's the canyon, here's the flood control channel coming through, here's the sedimentation basin we talked about a minute ago. And then I added these arrow indicators that are also interactive elements. And after the flood, what I did is I went around town and I captured still photography of the aftermath of the event. And then I went just this spring and I went around and I captured the same areas and then I put them together in this presentation of, what did it look like, the aftermath, and then, what does it typically look like, so you've got some benchmark. And so as you go through these drone imagery components, you can explore these different points and what they look like from photographs. The other element I'll point out in this inset map in our navigation are these little red buttons, and those are to video clips, and I'll get to that a little farther into the presentation here. So we can come around here and we can basically walk down this event. We come down farther in the canyon, we start to look into these neighborhoods. How did it affect, when these floodwaters came through, how much debris did it carry? You can look and see how high the water got on the sides of these structures, what it looks like today. Here they've brought the flood channel through the neighborhood. I'm not going to make you look at all of these, but so you come on down here. We're coming down farther on Canyon Avenue, and like I called out in my introduction segment, here's this choke point. So this flood channel comes down into the middle of this neighborhood, and it allows 400 CFS to go underground, but then this overflow comes and it runs on the surface, and that's problematic. You can see it brings debris all the way across the street. You can see the flood level on this structure here. And then it runs down Canyon Avenue. So you can follow it on the map. You can see how it comes down Canyon Avenue. I've got some more VR down here where you can look and see more of the fallout. Here's a pickup truck that was washed down into somebody's front yard, and so on. And so the flood continued down Canyon Avenue into this sort of split point here that you see on the map. And you come down here, what's been done since the flood is they've installed these floodgates to channel the water one direction. And so what they're trying to do here is this is the left-hand side that goes down canyon. They're trying to prevent this in the future and send it all the other direction. And so, let me bring this around. This building is in the path of the natural flow of this canyon into the confluence with Fountain Creek. So now the engineers have designed and constructed these flood walls through here to bring the flood waters around this building, and that's what this stuff is. There's a little staircase over the top of it, but there's a 4-foot flood wall here now along Park Avenue. Here's debris left from that. Again, this is a 1.38-inch rain event that created this problem. Where this actually ended up, this particular event, the best image I have here is, it shows how this culminated in this park and it actually reached its confluence with Fountain Creek. So you can continue to go around here and look at how it affected this stuff. Here's where it came along this building. You can see how high the flood line is. The water came that high on that building. All this debris left over. You come around. There's another drone image here we can look at. So now we're looking back up the canyon. Here's the bridge where we started this adventure, and we've come all the way down here with drone imagery and still imagery telling it in still photography. It culminates down here. It comes both ways around this building, and it comes through these pedestrian areas. There's a restaurant in this building. You can see there's a flood line inside of this restaurant. That's how high it came in here. Left all this debris. Here's what it typically looks like. And then this pedestrian mall. This is a Penny Arcade and a pedestrian area. So it came through here. You can see the water line, the rotunda of the building, the amount of water that's still standing in there and the aftermath. So this communicates, what happened, where it came down, and the aftermath. And then what I did is I crowdsourced 2 video clips, as you might imagine. In this day and age, all of us are generally walking around with a device that can record video in our phone. And so I crowdsourced 2 of those and put some metrics to them to give the viewer some idea of what flow this is. But this then communicates the chaos and the magnitude of the event when it happened. So the still imagery doesn't really do it justice as far as its magnitude and the amount of water, what that looked like if you were a pedestrian on that street, what you would have to contend with. So this is the upper part. I'm not going to run this whole thing. So I call out leader lines on the map that shows this video clip covers from the Highway 24 bridge down to about midway. And then this other video clip, I'm going to show you more of this. This is where it comes into the park. You can just see that, again, the magnitude. This is a 1.38-inch rain event. What this caused in the downtown core. Here's a refrigerator coming down from a home. You'll see cars floating by. I mean, this is a real dangerous situation. So this guy walks around where this split place was. There's a post office over here he walks up to. Again, you can see it. There's that building we looked at up close, the water levels on that, the destructive nature and the force behind it. And the blackness from the water is from the burn scar. It's bringing all that charred material down into town. So as he continues to walk around here, here's that split point where it went down Canyon Avenue and Park Avenue. You can see where it hits that the existing wall that was there. And then as he walks up Canyon where it just came down, you can see water shooting straight up in the air. What that is you heard me mention that underground box culvert. That box culvert is under so much pressure, it's blown the manhole cover off of it, and it's blowing that pressure up through the sheet flow that's coming down the road. That tells you, just how much elevation loss it's experiencing through that section. Okay, so that's the end of the presentation. Interestingly enough, after I submitted this for this conference, in the ESRI conference mid-July, Deanne Criswell did a presentation at their plenary, and she calls out the need for FEMA to start concentrating more on resilience and building resilience into communities to help them withstand these events. And so there's a couple quotes here. We've got to pull out resilience out of the shadow of response and recovery. And her closing comments is, for FEMA, is resilience is our mission. So that's my presentation. We'll open it up for questions.
We are out of time for questions right now.
Okay.
I'm sorry to say that. Please be sure to, that was fascinating. The combination of the